You've been asked to go get the chairs for both the Rocks, Paper, Scissors Championship and the basketball banquet. How do you solve multiplication word problems that don't ask you to find rows and columns? In this lesson, you will learn a strategy of solving multiplication word problems by using your knowledge of arrays to draw diagrams. Let's review arrays. One strategy to visualize a multiplication problem would be to create an array. And you know that when we're talking about arrays, we're using the terms rows and columns. So this says we have 5 columns and 2 rows to give us a total of 10 apples. We can also switch the factors here, which switches the vocabulary, which switches the array. So this says we have 2 columns and 5 rows, which still gives us a total of 10. Here's the mistake you want to avoid. When you read the multiplication problem, you're looking for number of groups, amount in each group, and total in all. If you're drawing an array, students sometimes may create their 5 groups, but when they go to mark down their 2 in each group, they see the 2 and automatically draw an additional 2 dots. Now, you know that 5 times 2 is 10, so when you fill out the rest of the array in this simpler problem, and you count up the dots, you can clearly see that you've drawn 15 dots. Remember, when you're creating an array, it's 2 dots in each group, not an additional 2 dots. Let's take a look at another way we can visually represent this array. Instead of calling these columns, I'm going to say we have 5 groups. And I'm going to draw 5 ovals, 1 for each group. Just like I'd say that I have 2 in each column, I'm going to say that I have 2 in each group. And I'm going to go ahead and draw my dots in each of the ovals. Count it up. It equals 10 in all. Let's look at this word problem. The Rocks, Paper, Scissors team needs chairs for their tournament. There'll be 5 matches with 2 players in each match. How many chairs will they need in all? Well, think back to what you know about multiplication. There's number of groups, number in each group, and number in all. So even though I don't see the word group here, I do see chairs they will need in all, which tells me it's going to be either addition or multiplication. And now I look and I see that word each, 2 players in each group. So I know that there's going to be the same amount repeated. And when I look at my 5 matches, I can link that up with the only piece of information that I don't see, and that's number of groups. So in this case, instead of groups, we have matches. So to visually represent these 5 matches, I'm going to draw 5 rectangular shapes. And I know that I need 2 players in each match. So I'm going to represent those with rocks, paper, scissors symbols. Now, each player is going to need their own chair. So if I look at this by match, I know that each match gets 2 chairs. And when I see this, I know that I have 10 chairs in all. Now, will the results still be the same if we were to switch the groupings? The basketball team needs chairs set up for their game. The 2 teams need 5 chairs for each team. How many chairs will they need in all? Once again, I have my numbers of groups, numbers in each group, and number in all. Chairs they will need in all. But this time, there are 2 teams that need 5 chairs for each team. So this time I have 2 groups and 5 players in each one of the groups. And I know that each one of my players is going to need their own chair. So the first team needs 5 chairs, and the second team needs 5 chairs, which gives us a total of 10 chairs in all. All you're being asked to do is get the right amount of chairs. You don't need to think about how they're going to be set up. So whether you had 2 teams with 5 players on each team, or 5 matches with 2 players in each match, you're still going to need the same amount of chairs. But remember, those groupings look a lot different. In this lesson, you have learned to solve multiplication word problems by using your knowledge of arrays to draw diagrams.